All right, the other thing we need to learn about is called our leading coefficient test. You know by looking at a function's degree, whether it is even or odd. You know, if you have 2, 4, 6, it's even. 3, 5, it's odd. And then you can also use its leading coefficient, and we call this the leading coefficient test. So if your function is odd, so 3 or a 5, your function you know is going to be looking where your end behavior is going down on one end, end behavior is going up on the other. Or, you know, it could be going up on the left, down on the right. So your graph goes up from left to right if your n is odd, and it goes up from left to right when your a value is positive. So if you have a positive a value, then the graph falls to the left, rises to the right. If it is negative, then that means your graph is going to be falling to the right. So that is for when your n is odd. Now when your n is even, I guess we'll be talking about that in the next example. So let's try to figure this out here for example 2. Describe your left hand and right hand behavior for the function. So basically what you're going to be doing is you're going to be figuring out, is your x value approaching negative infinity or positive infinity as x is approaching negative infinity, and is your y approaching positive or negative infinity as x is approaching positive infinity. Well, where in the world do I get this from? Well, this is from your picture, and you can tell this right here states your y value is approaching positive infinity as x is approaching positive infinity. So you always have a positive x and a negative x. Here, this is talking about how your y value is approaching negative infinity as your x is approaching negative infinity going to the left. So anytime you have x is approaching negative infinity, this is your left side. Notice up here, x is approaching negative infinity, this is your left. And anytime you have x is approaching your positive infinity, this is your right side. So this would be your right. So what we're going to do is, for this first problem, you gotta be thinking, here's our left side, okay, because x is approaching negative infinity. This is going to be our right side. So we have to try to think of, maybe come up with a little sketch for this graph. So if your degree is odd, that means you're either going to be going up from left to right, or it's going to be going down from left to right. So in this case, your first number is a positive coefficient. So your a is positive, that means you're going to be using this graph. So on the left, this is where x is approaching negative infinity. On the left here, your y value is also approaching negative infinity. Now on the right side, this is the right side of your graph. This is where x is approaching positive infinity. It's got to be going the opposite direction since you are odd. So it's positive infinity. So let's do the same thing for b. Now this one has f of x is approaching blank. And you always set these up the same, no matter how many degrees you have. I always like to put the left one on top. Sometimes your book will put the right one. You just have to know the difference between your left and your right. And that all comes down to knowing which one's positive and which one's negative. So x is approaching negative, that's always your left side. X is approaching your positive infinity, that's always your right. So if we look at our function here, it's odd. So we know, now this is going to have 4 curves in it, but we know it's going to be either going something like this, or it's going to be going something like this. I put an extra curve in there. So if this is a negative number, that means your graph is falling from left to right. So we're going to be using this graph. So on the left side, your x is positive infinity. And since this is an odd function, this must be negative infinity on the right. For odd functions, your f of x's are always the opposite sign. Evens, which we'll find out in the next example, will always be the same.